कभी कभी लगता है कि अपन ही भगवान है।
Hi everyone.
Right. Today I am trying to start a logistic regression. Which one? Logistic regression. So today we'll see what is logistic regression. What is logistic regression? Right. Today we'll see what is a logistic regression. So what is the meaning of logistic regression? Here the word regression is there, but despite its name, we will work on classification only. The name is only regression, but you don't think so that here we'll work with the regression. So logistic regression, despite its name, it is a linear model of classification rather than regression. So even though the name of this algorithms, the approach is logistic regression, the name of this approach is logistic regression, but still will work with classification only. Still will work with classification only. You are getting my point? Still will work with classification only. So let's see what is logistic regression. When you are trying to put in Wikipedia, what is logistic regression? Logistic formula, you can see here. This is our logistic function. So what is meaning of logistic function is, first describe theory parts, then we'll come back to that function. Logistic regression, despite its name, it is a linear model of classification rather than regression. It is a linear model of classification rather than regression. Logistic regression is also known in the literature as a logit regression, maximum entropy classification, or linear classifier. In this model, the probability describing the possible outcomes of a single trial as a model using the logistic function. A logistic function or logistic curve is a common S-shape called sigmoid with equation. So don't worry. What is the meaning of logistic function? We'll see here. First, we'll understand logistic function, and then we'll come to the logistic regression. Then we'll come to the logistic regression. So, logistic function is nothing but when this is the formula of logistic function, fx is equals to 1, fx is equals to L by 1 plus e k power minus k x minus x0. What is the formula? Formula is L by 1 plus e k power minus k x minus x naught. This is the formula of logistic function. What is the meaning of logistic function is why we are approaching logistic function. Earlier, let's suppose I want to know that I'm sharing here women's list. Okay, 40 women. I want to know that among of these 40 women, how much numbers, how much women is suffering from cancer or not. So you know that I'm giving the data. I want to know that the woman is suffering from cancer or not. So the output will be only yes or no. Yes or no. Let's suppose tomorrow I'm giving the data, some medical data. The data is related to diabetes. The data is related to diabetes. Some parameter is defined. The BMI is giving. BMI is giving, right. Insulin power is giving. All the parameters, input parameter is giving. On the basis of that, I want to know that you are suffering from diabetes or not. You are suffering from diabetes or not. So here you can see the output is only in between yes or no. Yes or no. So I'm giving input data. On the basis of that input data, if your output is only in between yes or no, 0 or 1, so that you can say there you can apply sigmoid, there you can apply logistic function. There you can apply logistic function. Why? The formula of logistic function is, you can say, L upon 1 plus ek power L upon 1 plus 1 plus ek power minus k x minus x naught, x minus x naught. So here we can see what is the value e. E is nothing but the natural logarithms. That means the Euler numbers. E is nothing but exponential. Let's suppose, as we know that ek power 0, the values will be 1. Ek power 1, the values will be same as it is. You have to learn some power, ek power 0, ek power 1, ek power 2. X naught is the x values of sigmoid midpoint. X not a sigmoid midpoint. So I want to make then, earlier we know that KNN, k nearest neighbors algorithms, KNN. In this KNN, all the distance through the Minkowski distance. If p is equals to 2, it calls Euclidean. If p equals to 1, it is called p equal to 2. It is called p equals to 2 Euclidean, and p equals to 1. It is called p is equals to 1. It is called Manhattan. Same here in logistic regression will work around only logistic function. Logistic function. On previous session, we work around only Minkowski distance. Okay, here we'll work around logistic function. So let's suppose the values of L is equals to 1 and values of L is equals to 1 and x naught is equals to 0. Let's suppose I'm putting here the values of, let's suppose I'm putting here values of L equals to 1, L is equals to 1, x naught is equals to 0, and k is equals to 1. K is nothing but the logistic growth. So I want to simplify this formula. After the putting this value, the formula will be 1 plus 1 by 1 plus ek power minus x. This is our sigmoid. You can see here, this is our standard logistic sigmoid function. When you are putting L is equals to 1, k is equals to 1, and x naught is equals to 0. When you are putting L equals to 1, x naught equals to 0, and k is equals to 1. So once you are putting k equal to 1, L equal to 1, x naught equals to 0, and 1 by 1 plus ek power minus x, the formula will become simplified. 1 by 1 plus ek power minus x, the formula will become so simplified. You are getting my point. So now I want to open one Excel here. Let's suppose here I'm writing x. X is nothing but input data. Then here our function is fx. Fx is nothing but our our formula. Fx is equals to, what is the formula? 1 by 1 e k power exponential minus x minus x. This is our formula. One second. Anyone have problem? One second. Page layout. One second. Why it's disabled? Zoom 100%. One second. Maximize. Now it's fine. We have x. Let me grow this little bit. No. So here you can see, let's suppose this is our x. X is nothing but input values, and what is our function? That means what function is, output will be, function is, so x is nothing but input. X is nothing but input. And over after the apply this formula, the output is here. Let's suppose it comes y. Output will be here. Let's suppose this is our y. This is our y. So let's suppose I'm putting in instead of x, I'm putting here in formula. Let's suppose what is the formula is 1 by 1 plus exponential of, formula is 1 by 1 plus, this is our formula, 1 by 1 plus exponential of minus x after the putting of this value, l equals to 1, k is equals to 1, and x naught is equals to 0. X naught is equals to 0. The formula will become l equals to 1, k equals to 1, and x naught equals to 0. The formula will become l equals to 1, k equals, if you are putting l equals to 1, k equal to 1, x naught equals to 0, formula will become 1 by 1 plus e k power minus x. 1 by 1 plus e k power minus x. Alright. So I want to put, instead of minus x, I want to put 0 here. The value will be become 1 by 1 plus e k power minus 0, that means 0, minus 0, that means 0. So as we know that the values of 1 plus e k power, right, e k power 0, it will become 1 by 2. So what is the meaning of 1 by 2 is nothing but 0.5. Nothing but 0.5. Same as it is, let's suppose you will, same as it is, tomorrow, let's suppose you are putting here, instead of 0, you are putting here 1, the values will be little bit increase. Instead of 5, you'll be getting 6 or 7. When you are putting 2, it will be increasing. 3, it will be increasing. 4, it will be increasing. It will be increased. Right. Same as it is, let's suppose tomorrow you are putting the values is ek power minus 2. Ek power minus 2. So minus minus plus, it will be decrease. It will be decrease. So you can calculate, you can put up to 0 to 20. You can put up to 0 to 20, and you can put here minus values also, minus 1, minus 2, minus 1, minus 2, minus 3, up to minus 20. So I want to describe this curve. You can say here, once I'm putting, you can say this is our x-axis. You can see here. You can see here, this is the x-axis, this is the x-axis, and this is the y-axis. This is the x-axis, this is the y-axis. X is nothing but x-axis is nothing but this one. I'm putting the values. This is our x-axis, 0, 1, 2, 3. I'm putting. On the basis of that, y will be here. Let's suppose I'm putting 0, so y will be 0.5. 0.5. Same thing you can see into this curve. When you are putting 0 here, 0 means nothing but x-axis. The values of y is 0.5. So once you will figure out whatever values you are putting, the maximum values will be 1. The maximum values will be the maximum values of maximum value of y will be 1, and minimum will be 0. This is the range. So all output will comes under the 1 and 0. You can see here, this is our maximum output 1, and this is the minimum. This is called y-axis, and this is called x-axis. So whatever values you are putting 100, 200, 300, and minus 100, minus 200, minus 300. The range of output will be, you will be getting in between 0 to 1 only. So that's why this is called sigmoid function. The output only in between 0 to 1. The output will be in between 0 to 1. The output will be in between 0 to 1. Output will be in between 0 to 1 here. Got it? So this is called logistic. This is called logistic function. This is called logistic function. You can see here. So this is our business problem statement. What is the business problem statement is? The data set is originally from the National Institute of Diabetes and Digestive and Kidney Disease. The objective of this data set is to diagnostically predict whether or not a patient has diabetes. So as we know that output will be only in between two parts, whether the diabetes is positive or negative. That's why we can apply here logistic regression. That's why we can apply here logistic regression. Based on certain diagnostic measurement included in the dataset, several constraints were placed on the selection of these instances from a large database. In particular, all patients here are females at least 21 years old of PIMA Indian heritage. Right. So the patient age is more than 21 years. I want to know that patient whether suffering from diabetes or not. The patient is whether suffering from diabetes or not. So how can we calculate that? So same as it is, as we know that we have a logistic regression is based on logistic function. That means, as we know that what is the logistic function? Logistic function is nothing but whatever your values you will be putting, the output will becomes under the 1 and 0. That's why, because our problem statement is based on yes or no, 0 and 1. So let's suppose as we know that yes, no, 0, 1, true, false. So automatically it will be sorting. As we know that how it will be sort. First it will come no and then yes. Even though in alphabet it's already sorted into the n and y. N and y. First n will come, then y will come. First n and 1. First 0 will come, then 1 will come. First false will come, f will come, okay, and then f will come, then true will come. So you have to follow in same order. Even though internally it will follow the same order. First n, y, n means nothing but 0, y means nothing but 1. 0 means nothing but false, and 1 means nothing but true. This is the scope. This is the scope. This is the n. This is the y. N means nothing but n means nothing but n means nothing but not y means yes, 0, 1, false, 2. That's why we are using logistic regression. Why logistic regression? Because the logistic regression based on internally logistic function, and logistic function, the formula of logistic function is fx is equals to 1 plus ek power minus x, ek power minus x. That means whatever input you are putting, like let's suppose tomorrow you are giving 200, or tomorrow day after tomorrow you are giving minus 300, is still the output will become false under the in between 0 or 1. The maximum value will be 1 and minimum will be 0. That's it. You are getting my point. Maximum will be 1 and minimum will be 0. That's why we are applying here logistic regression. So let's see, I want to open, we'll work on, as we know that for using any machine learning, you have to import required modules. So what all the required modules is there? Pandas is there, train and test split is required, logistic regression will be required, and accuracy score is required, confusion matrix is required, and classification report is required. Classification report is required. You're getting my point? Classification report is required. Got it or not? Guys, am I audible? Guys, am I audible? Due to internet issue, we'll continue tomorrow. We'll continue tomorrow. Meanwhile, you can go through with Wikipedia logistic concept. Thank you so much.
Okay, sir. Thank you.